Please take a look. Focus up here. So here, I saw some good stuff, but I think we need a quick little review. So first thing we might do here is like we're going to look at the fraction that's inside the square root. Well, that reduces to 9/10, right? So the first thing we might do then is just break this down into a simpler square root, the square root of 9/10. Okay, now what? Well, now we've got to split this thing apart. We got to split it into a separate square root on the top, which is the square root of 9, and the bottom, which is the square root of 10. Square root of 9 is what? 3. So that one simplifies. Square root of 10, can we simplify that? We can't, right? The factor tree for 10 would just give us a 2 and a 5, so there's no couples, only singles, so nothing comes out, right? So that leaves us with 3 divided by the square root of 10. Now, here's where I think we need a little reminder. Our rule is no tenths in the basement. We have a square root of 10 stuck in the bottom. Tegan, what do we need to do? Top and bottom, right? Correct. So we're going to multiply both the top and the bottom by whatever the square root that's stranded in the bottom is. Well, in this case, that's a square root of 10. Okay, what's that going to give us? Well, on the top, we're just stuck with 3 times the square root of 10, right? Square root of 10 is stuck inside. The 3 is already outside. What about the bottom? What's the square root of 10 times the square root of 10? 10, right? Remember that rule. Here's our rule for that, real quick. If we multiply a square root times itself, it cancels the square root every time. So on the bottom, we get a 10, and that's our answer. Okay? Good? Another one? Want to try one more of those? Okay, I'll give you another one. Try this one. How about? Let's do.
Over what, Peyton? He's thinking.
I'm thinking. Just a second.
But like 622. 20.
Try that one.
Bro. Yeah.
Try that one. Okay, for today, here's all we got for today. And this is, by the way, this is our last topic. Oh, and put that away, please. This is our last topic before we're going to do a test. Rather than, I'm going to break up this unit because it's kind of a big unit. We don't want to do one huge test at the end, right? So we'll do this test over this stuff, and this will be it for our semester, right? This will be it for all the tests this semester. We'll do this. Let's see. So today we got to kind of figure this out here. So I think I could make it available on Friday. That would be good because if we did it on Friday, then that would give you next week to do retakes on it before final, before the end of the term. Does that make sense? Yep. When do they actually get sent out? I don't know. Semester ends is next Friday. You guys are in school next Friday, right? Okay, yeah, I'm not going to be. I won't be here next Friday, so we'll just plan on that being a day for you guys to to retake any test if you need to on that last day or finish up. Technically, the last day they just published the last day for missing work to be turned in for the school is the 20th of June. That's coming up, right? Ooh, that's really coming up. I mean, January. What am I say? June, January, right? So that's this Friday. Okay. So we just got that email this morning. So that's it. That's the final day. We're not supposed to take any work after this Friday. But I will take everything. I'll take anything for full credit through Friday. Okay. So keep that in mind. If you're missing homework and you want to get that in, this is the week to do it. So let's say test Friday. That'll give us an opportunity. I'll give you guys. You got a review assignment to work, or you have this new assignment to work on. I'll assign a review assignment. Man, I almost think we need to go Monday. We'll see. If we can do it by Friday, we will. Okay. But I want to give you a review assignment to go through and prep for the test. If worst comes to worst, we could do it Monday, and then I could have retakes like Wednesday, Thursday, Friday or something. Okay. That sound good? And then I think we'll probably I can't imagine we might get through like one section in the next the next part, but that would be the most. Really, pretty much this is it. We'll finish this up for the semester and call her good. And then we'll start with the next material after this would be the very beginning of semester 2. Okay, that makes sense to everybody? That sound like reasonable time frame? Everybody's comfortable with that? Okay. All right. So this last topic for this semester is going to be another technique for solving quadratic equations. What have we done so far? Well, we've solved quadratic equations by factoring, but now we've been working with square roots because we have another possibility. If we start with an equation like this one, okay, look at this guy. If we want to find all the solutions of this equation, it's quadratic. How come that's quadratic? How do we know right away? There's an x squared in it, right? So it's quadratic, okay? That's the biggest power of x is an x squared. We could factor this, but there's an easier way. Anybody see maybe a simpler way to solve this equation? Yeah, right? This follows the same rules that we used in our linear equation sections way back earlier in the year. What did I always say? If you can point to a single x or a single variable, it doesn't have to be an x, but let's assume it's an x. If you can point to a single x, then you can always isolate it with inverse operations. And solving means isolating, right? So here's an example where this time we don't need to factor because there's only one x. In the past, like when we were factoring stuff, we had x squared terms and x terms, and we never could point to a single x, right? Those were problems that looked like this. I had stuff like this, like x squared minus x minus 6 equals 0. Look, I have x squared terms and x terms, and there's nothing I can do about that. I'm never going to have a single x, so I can't isolate. We had to factor. This is different, right? This time I can point to a single x, so I just have to use inverse operations. Well, follow the PEMDAS. That's it, inverse operations. What's my first step to isolate x there? Yeah, subtract 44. Look, it's telling me add or subtract. Okay, if I need to, I do. I need to subtract 44. So step 1 is subtract 44. Okay, good. Oops. So then I've got 4x squared equals 16. Now what? Yeah, so I work my way up. Next would be multiply or divide. Yeah, divide by 4. Okay, so there's step 2. That leaves me with x squared equals 4. Now what? Exponent, right? The next thing I see is this exponent. So step 3 is I have to undo that exponent. How do I undo the exponent? Well, I mean, I could, but we're not going to try to avoid factoring here, right? How do I undo squaring something? What do you think? Square root, right? So I would just square root both sides, okay, to get rid of the squared. And it does get rid of the squared. Okay, so then what do I end up with for my answer? So I would get x equals 2, right? Does anybody see another solution there? We could check that and it works. If I plug that back in, x equals 2, 2 squared equals 4, so that works. Is there another one that would have worked though? What else could I square and get positive 4? Negative 2, right? Well, where'd that come from? Okay, here's where it comes from. There is a missing step that nobody ever shows, and this is it. If I square root both sides, I get the square root of x squared. But what is that? If we think about that, let's just turn that into a function and analyze it for a second. I'm going to call f of x that, the square root of x squared. Let's just try something. If I evaluate that function at 2, so I plug 2 in for x, what's my output going to be? I get the square root of 2 squared, which is 4, which is 2. I input a 2, I output a 2. Okay, seems like f of x equals x, right? Seems like I could have just changed that into an x, and when I input a 2 for x, that's my answer. Okay, how about this one though? What if I input a negative 2? Then I'm going to end up getting the square root of negative 2 squared. That's also the square root of 4, which is also 2. We've dealt with a function that does that stuff, right? Think about this. What function have we worked with already? When I input 2, it would output 2, but if I input negative 2, it's going to make it positive 2. Absolute value. That's it, right? So it's absolute value. There's our missing step. The square root of x squared is actually equal to the absolute value of x. So it's the absolute value of x that equals 2, not x that equals 2. Kenny, what did we do when we solved absolute value equations? If we had an isolated absolute value equal to a number, what were my answers, my solutions? Remember that? It's been a while, right? But if I had something like this, if I had an isolated absolute value equal to a number, then whatever was inside the absolute value bars was always equal to the positive or negative number. You guys remember doing that? Clear back in Unit 1. So what would my answers be then? Yeah. What's inside is an x. That's got to be equal to the plus or minus of what's outside. So I've got to include that plus or minus there, right? Okay, do we have to show that absolute value step every time? No, we don't. We don't. We take a shortcut. Here's our shortcut. Whenever we square root both sides of an equation, we know that we always have to include that plus or minus. It's called the square root property, right? If I start off with the equation x squared equals k, where k is some number. If x squared equals k, then x equals plus or minus the square root of k. So you have to include that plus or minus every time. That's one of the most common simple mistakes that people make in algebra is they forget that plus or minus. Okay? All right, so let's try another one. Okay, actually, you guys try one. Try that one. Jump to the boards and try that one. You want to do one together first? Okay, let's actually have a seat. Let's do one together real quick, and then I'll give you another one. Let's try this one together. So what are my steps going to be to, can I point to a single variable, thumbs up or down? I can. So what do I do? Isolate, right? I'm going to isolate. I can point to a single variable. So we can isolate. First step, add 5. Cancels the 5s, and I get 5y squared equals 37. Now what? Divide by 5. It is a fraction, but that's all right. So then what's that going to give me? I'm going to circle back up here. So we get y squared equals 37 fifths. Now what? We don't have to do the absolute value part. Yeah, but we don't want to write a mixed number. We'll leave it as a fraction. Okay, but what do I have to do? I still haven't isolated the y. What do you think? Square root, right? So I'll square root both sides. That cancels the squared, and I get y equals, what do I have to always include if I'm square rooting an equation? Plus or minus. I get plus or minus the square root of 37 fifths. Well, let's start to simplify that. How would I simplify the square root of 37 fifths? What would I do? I can't reduce that. 37 over 5 doesn't reduce. So what do I need to do to that fraction? Yeah, I got to split it up, right? Square root of the top divided by square root of the bottom. Separate the square roots, right? So we get square root 37 over square root of 5. Am I done? What's wrong? Yeah, no tenths in the basement, right? So what do I have to do to fix that? not by 5, by square root of 5. There we go. Multiply top and bottom by square root of 5. Okay, so then what's my answer going to be? I've got my plus or minus out front. Have to include that. On the bottom, what do I get? 5. On the top, what do I get? I mean, I'm going to get just a big square root, aren't I? Right? Okay, so I get square root of 37 times 5. That's 175? 185. Whoops, 185. Yep. Okay, and could I break 185 down? I can't. And I know right away that I can't. Here's why, because what would the numbers be in my factor tree if I did a 185? We already know what they would be. 37 and 5, right? That's what I multiplied to get 185. 5's prime. What about 37? Does anything divide into 37 other than 1? No, it's prime too, right? So there are no couples coming out of this. So everything is stuck inside the radical. So these would be my two solutions. Positive the square root of 185 over 5 and negative the square root of 85 over 185 or over 5, right? Okay? Give me thumbs. You want to try one? Okay. Try. Here, let's make I'm going to make one up. Try this guy. Try.
Do that.
Go. Try that. It is light work. Okay, what do we do here first? Add 2. There we go. Okay, so if we add 2, that gives us 5y squared equals negative 30, right? Now what? Divide by 5. All right, like it. And that gives us y squared equals negative 6. Now what? Okay, what's going to happen if I square root here? Somebody raise a hand and help me out. What's going to happen here that's kind of a problem if I square root both sides? Okay, it's a negative. All right. So can I take the square root of a negative number? No, we have 2 rules for real numbers. I can't divide by what number? 0, and I can't take a square root of a negative. Okay. So this one right away, because we're trying to square root a negative, we already know that this one is going to give us an answer that's not a real number. There is no real solution. Okay, we could just stop. We don't have to do any more. As soon as I know I'm going to be square rooting a negative, I'm done. Okay, can't do it. All right, we did that one. Okay, what about this? What about this? So now, again, give me thumbs. Can we point to a single variable? We can. Right, we can. Okay, there it is. So I should be able to use inverse operations. I just have to be a little bit careful with this. I have to follow the inverse operations line by line. Got to be very careful with it. So what's the first thing I'm going to do? So what's the suggestion? Square the thingies inside the parentheses. Okay. What would that give me if I square the thingies inside the parentheses?
3x minus 16 or plus 16. Right? 3x squared.
So, but I'd have to square the whole 3x, right? Okay, is it equal to 9x squared minus 16? No, it's not. It's not. It's not. 3x minus 4 squared. Nope. 3x minus 4 squared equals 3x minus 4 times 3x minus 4. It's way more complicated. I'd have to FOIL this whole thing out, right? Does that make sense? Right, I'd have to FOIL it and I'd have to add like terms. We don't want to do this. This is not that's not our approach. That's not order of operations, or that's not inverse operations. Inverse operations, remember, we go clear back to the stuff we did with solving linear equations. When I'm applying inverse operations, I should get to cancel something every time, right? If I'm trying to isolate the x, every step should get me one step closer to that. Every step should make the left side one step closer to the x by itself. That did not help me do that at all. In fact, it made it messier, right? No, it wasn't a bad idea. And honestly, we could do this. If I were to FOIL this whole thing out and collect all the like terms and subtract 76 and do all that work, I would get a great big ugly trinomial on the left side that equals 0 that maybe I could factor, but maybe I couldn't too. Okay, so we don't want to do that. What do we do instead? We're trying to isolate. So what's the first thing I'm told to do? Add 5, right? I'm told to add or subtract. Now keep in mind that parentheses, I don't get to parentheses until the very end of inverse operations, right? So all the stuff that's in parentheses is off limits until I get clear to the top of that inverse operation list, right? So outside of parentheses, step 1 is add 5 to both sides. All right. If we do that, it's going to cancel the 5. I'm going to get the quantity 3x minus 4 squared equals 81. What's next? What's next? Is there anything to multiply or divide outside parentheses? No, nothing. So then next step, exponents, do I have to deal with an exponent? I do, right? So the next step would be exponents. Well, I've got a 2 there as my exponent. How do I undo a squared? Square root, sure. Okay, so next step is square root both sides to cancel the squared. So then on the right side, what am I going to get? 9. Not quite, close. Plus or minus 9. Can't forget the plus or minus. Every time I square root both sides, why is that phone out there? No, that's good. Put that away. Thank you. So we're gonna add a plus or minus because I square rooted. We have to have that, right? What about the left side? What's left? 3x minus 4. Do I need parentheses? I don't really need them anymore, do I? The only reason I needed them before is because that whole thing was being squared, right? Now that we've undone the squared, I don't need them anymore. Okay, good. So it's looking better. Now it looks much, much simpler. What are the last 2 steps to get that x by itself? Add 4, then divide by 3, right? Okay, I'm going to add 4 to both sides. Okay, you guys are used to doing it this way, I believe. Tell me if this is right. You would have done this in the past. You would have split this into a positive 9 and a negative 9 separately and added 4 to both of those. Is that correct? What would you have done? That's it? Okay, I got a better way. Do it this way. Leave the plus or minus sign there. It's your friend. It's going to make things easier to write and shorter to write. And anytime you add or subtract something to both sides, and I already have a plus or minus, put the number that you're adding or subtracting in front of the plus or minus. So this time I'm just going to put the 4 there. Okay? Why does that help? I'll show you. So those guys cancel. I get 3x equals 4 plus or minus 9. What's my last step? You already told me. Divide by 3. Okay? So if I divide everything by 3, means I have to divide the whole right side by 3. These are my solutions. I get x equals 4 plus or minus 9 over 3. The nice thing about this is I did the algebra one time and I get both answers. All I have to do now is I'll take the plus sign and simplify. If I choose the plus sign, what do I get on top? 13. What do I get on the bottom? 3. So my solution is x equals 13 thirds. Okay. What if I choose the minus sign? What do I get on top? Close. -5. On the bottom, I get 3. So probably a better way to write that, I'll put the negative out front. X equals -5 thirds. Okay, negative over positive is negative, right? Okay, give me 1 to 5. Does that make sense? Okay. Why don't you guys, did I not have one for you to practice there? I didn't. Okay. Where's the practice one? Oh, I know, they're at the end. Yeah, we'll go through a couple more examples and then I'll let you guys try one on the board at the end. Okay, what about this one? First step? Okay, good. Subtract 10, right? Because outside of parentheses, add or subtract. Yes, subtract the number that's outside of parentheses from both sides. Okay, those guys cancel. So I get, what, negative 196? Okay. Divide by -2. Okay, I got to divide, multiply or divide by anything outside of parentheses. So step 2. Divide by -2. Cancel those guys. Now I've got 2x plus 3 squared equals negative over negative is positive. So it's going to work, right? When I square root, I'm going to be square rooting a positive. So we're good. Half of 196 is 98. Next step. Square root. Yeah, now I've got exponents, right? So step 3, square root both sides. That cancels the squared. That's good. So on the left side, it's looking pretty good. 2x plus 3. How about the right side? What do I need to include? I square rooted both sides, so what do I need? Plus or minus, right? Can't forget that. Every time I square root both sides, I automatically, before I even start thinking about it, plus or minus. We could simplify 98. Square root of 98. What could I do? Divide by 2. Okay, so I get 2 and no. Half of 98? 49, there you go. Okay, 2's prime. Does the 49 break up? 7 times 7. So look, I get a couple of 7s, single 2. So what does that simplify to then? Yeah, couples go out, so I get a 7 out. Singles stay in, so I get a 2 in. Okay? What's next? Well, okay, I got to subtract 3, don't I? Right? Because now I'm still trying to isolate that x. So next I'm going to subtract 3. Where does it go on the right side? Front of the plus or minus. Good. So we're going to put our -3 there. Those guys cancel. And I get 2x equals -3 plus or minus 7 square root of 2. Last step, divide by 2, and we're done. And that's it. Those are both of my answers right there. I get x equals -3 plus or minus 7 radical 2 over 2. That's both of them. Now, in Math Excel for school, They always tell you to separate all your answers with a comma. So how would I have to write this in Math Excel for school? How many solutions are there? 2, right? One for the plus, one for the minus. How do we read that? Plus or minus, right? So I'm getting 2 solutions, the positive, the one I get for the plus, or the one I get for the minus. So what would I have to write then? Well, I'll just write it with the plus sign. -3 plus 7 times the square root of 2 over 2. And then I write it with the minus sign. -3 minus 7 radical 2 over 2. And when you put those in, I think you could even like type that one in and then copy and paste it and just change that sign in the middle. Save yourself a little typing, right? Give me 1 to 5. Is that working? Okay, good. All right, so last example I want to go through with you guys is this one. So this is really not super difficult, but how do you do it? It says find all x-intercepts. We're trying to set this up so we could solve an equation. How can I turn that question into an equation? What does this have to do with it, these x-intercepts? What's important about that? What happens at an x-intercept on a graph? Crosses the x-axis. What's true every x-intercept, so every point then that's on the x-axis, because those would be points on the x-axis, what do they all have in common? What's the same for every x-intercept? Say it again. Well, okay, I mean, they're crossing a horizontal line, but which coordinate is always, the x or y coordinate is always going to be the same for every x-intercept? The y coordinate's always what? 0, right? Because it's on the x-axis, so they don't go up or down at all, right? They're on the y-axis. So we know x-intercepts are where y is equal to 0, right? Well, y is the same thing as f of x, isn't it? Right? F of x is just a fancy name for y. So that's telling us f of x is 0. I would just replace the f of x with a 0 because the x-intercepts are where f of x equals 0. And then wouldn't I just get the equation 7 times the quantity x minus 2 squared minus 5 equals 0? Right? And then I could just solve that equation, couldn't I? Say it again. Well, but because I still have to isolate the x, right? So let's quickly, one last time, let's isolate the x here. First step, everybody, what am I doing? Add 5, good. Okay, so add 5. Those guys cancel. That gives us 7 times the quantity x minus 2 squared equals 5. What's next? Divide by 7, right? Got to divide, multiply, divide outside of parentheses. So we divide both sides by 7. So x minus 2 squared equals 5/7. Now what? Square root to undo the squared. Okay, and so that's going to give me, I'm going to do that, right? So now if I square root both sides, I get x minus 2 because I just canceled the squared. X minus 2 equals, what do I have to always include if I square root both sides? Plus or minus. And I've got the square root of 5/7. Well, let's simplify that. Square root of 5/7, I can't reduce the fraction, but what would I need to do? First step. Say it again. Okay, but I mean, I guess first I got to split it, right? I got to split it into separate square roots. Square root of 5 over square root of 7. I can't simplify either one, but there's no tenths in the basement. So what do? Multiply top and bottom. Oh, okay. All right, we'll finish up this guy, maybe do a board work problem or two tomorrow, and then I'll let you work. Okay? Good job. Yes.